Hello Calculus and welcome to 9.4. This is Lagrange multipliers, and what we use these for is when we have two or more variables and we have constraints. So like I want to maximize this area, but I want to do it for this amount of money, or things on that order. So let's have some fun. Make sure your notes are out and let's go. All right, this should have been when a problem requires more than two variables. It's two or more variables and one or more constraints. So like an example, I want to maximize floor space of a building at a fixed cost. So I have floor space, we know is two variables because that's area, and fixed cost is my constraint. So let's show you what this looks like. We're going to use lambda. So a relative extrema function subject to this constraint g of x. So among these points, x, y, there has to exist a value lambda such that the first derivative of x has a lambda equals 0, the first derivative with respect to y has a 0, and the derivative with respect to lambda has a 0. Okay, this happens when the function x, y, and lambda equals the original function minus lambda times the constraint. So let's show you what this does. Lambda is just a Greek letter that we use to represent our Lagrange multiplier. Okay, I'm going to give you a function. All right, I want to find the minimum value of this function. My constraint is x plus 2y equals 24. Both must be given in order for you to do this. Okay, step one, you always set the constraint equal to 0 because this has to be equal to 0 so we can plug this portion into our equation. Step two, we create our equation. So it's the first one minus the lambda times the constraint. Good to this point? Distribute your lambda. That's all I've done here. So we have our equation ready to derive. So now we take the first derivative with respect to x, up here. So that's 10x, nothing, negative y, negative lambda, done. Then you take it with respect to y. So this is nothing, 12y, negative x, minus 2 lambda. Then you take it again with respect to lambda. So the first three go away, and you have negative x, negative 2y, plus 24. So these are the three derivatives that we need. Okay, step 4, you set the derivatives equal to 0, and you solve. This is triple elimination, if you remember this. So we got these two derivatives. If you look here, this one does not have lambda in it. So we always take the first two and we eliminate lambda because our third one only has x and y. So that's how you know which two to pick. So I pick these first two. I want to eliminate lambda, so I'm going to multiply this one here by my negative 2. That's how we got the negative 22, 2 lambda, and theta are 0. Add these up, so this here crosses out. You got negative 21x plus 14y equals 0. We've done our elimination. Now I have to eliminate x or y. So we're going to go through here. We're going to rewrite this equation. So this is negative x minus 2y equals, 24. You can eliminate x or y. It doesn't matter in this case. I chose the y because it was a smaller number. So I multiplied this entire thing by 7. That's where the negative 7x minus 14y equals negative 168 came from. I can talk today. Negative 28x, so x equals 6. We now have 6, so we can plug it into our original. I plugged it into this one, and we can solve for y. And y equals 9. So my point that I'm looking at is 6, 9. Now, is it a min or is it a max? Because we used a Lagrange multiplier, you can't really tell. So what you do is you plug in the 6 and the 9, and we get 612. And then you pick a value that is close. So I let y equal 9.1. You could have picked x too, it doesn't really matter. Plugged in the 9.1 and I solved for x. So this is a point that is close. So I plugged in this point, and so this is y, so I'm above the y because I'm at 9.1, so I went up. So we do 9.1, plug it in, we get 612.28. Okay, 612 is above my 612 here. So since this is above, this here must be a min. So if I ended up with something lower, then this would have been a max. So nothing too earth-shattering there. All right, pause and try yours. See if you get your steps right. Oh, I forgot to give you your constraint. I'm sorry. So your constraint is, and I knew I need to type that too. Your constraint is 2x plus 3y equals 12. All right, now pause and do yours. So step 1, we set our constraint equal to 0. So 2x plus 3y minus 12 equals 0. Step 2, we calculate our function. So we know our function of x, y, lambda, that's a lambda, second x, is equal to your original minus lambda times your constraint. Okay, let's simplify that out so we can do our derivatives. So we still have your x squared plus your 2x plus your 9y squared plus your 3y plus your 6xy. Now distribute your negative lambda. Negative 2x lambda minus 3y lambda minus 12 lambda. Lambda is hard to draw on here. All right, now we have to do all of our derivatives. We have to do our derivative with respect to x. And we're going to get 2x plus 2, nothing, nothing, plus 6y minus 2 lambda. Okay, now we have to do our derivative with respect to y. First one's nothing, nothing. Third one is 18y plus 3 plus 6x minus 3 lambda. And then your derivative with respect to lambda. I forgot to put my lambdas in here. Is equal to negative 2x minus 3y minus 12. All right, now we have to do now when you look at this one here, solving for lambda isn't as easy as it was before. And I am out of room. Okay, let's go here. We might have to erase part of this to show you how to do this problem. Okay, so when we're looking at these, we need to get rid of lambda. And I think we're going to solve for lambda and show you a different option. So these are equal to 0. So let's get lambda by itself. So that means that 2 lambda is equal to 2x plus 2 plus 6y, and divide by 2. So lambda is equal to x plus 1 plus 3y. All right, so now let's do the other one. So we're here. So that means 3 lambda is equal to 18y plus 3 plus 6x divide by 3. So lambda is equal to 6y plus 1 plus 2x. All right, now when we look at this, we can solve for x or y. So let's put these equal to each other. So we're going to have, let's do another color here. So I know that x plus 1 plus 3y is equal to 6y plus 1 plus 2x. I'll subtract the 1's and those are gone. Let's subtract the x and the y. So that's going to give me a minus 3y on this side equals x on this side. So x equals a negative 3y. Well, now that I have x equals a negative 3y, I can substitute this into my lambda equation. I'm sorry, this is all over. So now we got a minus 2 times negative 3y minus 3y minus 12 equals 0. So we're still solving here. Solve this, and we got 6, 7, 8 minus 9y equals, I'm sorry, I did my math wrong. That's a positive 6 plus a 3. That's 3y equals negative 12. So y equals negative 4. Well, if y equals negative 4, I can plug this in here. So negative 3 times negative 4 is x, so x equals 12. So my point is 12, negative 4. All right, since I already told you it was a min, you don't have to actually prove that it is a min and you're done. I hope you did well with that one. Sorry about not giving you enough room. Okay. These are just the rules for using a Lagrange multiplier, was what we've just done. Just written out in formal steps. Okay, let's try one now with actual work. Okay, a builder wants to maximize floor space in a new building. Well, I know floor space is area, so I know that's like XY. We know this is area. While keeping the cost fixed at $500,000, so this is what I have to fix. The building will be 40 feet high, the rectangular floor plan, and 3 stories. X is the width, Y is the length, area equals XY. So we know the cost is XY times 20Y times 20X plus $474,000. This is given to us. Now I want to maximize this cost at $500,000. So we set it equal to $500,000. I must set that equal to 0. So we bring the 500,000 over, and here is my equation. This is my constraint. All right, because this is what my money is. My equation is XY, my area. So I take my original XY minus lambda times my constraint, distribute your lambda. Now we're going to do the derivative with respect to X, the derivative with respect to Y, nothing different than before, then the derivative with respect to lambda. Okay, we've done our work. Now we can actually do our calculations. So we set them equal to 0. And again, we need to solve these things. So the double variable here causes an issue. This is something new. So we can't just use straight substitution. So what we do here is we solve for lambda like we did last time, set those equal to each other, and now let's solve this. And we get xy plus yx plus 20 equals yx plus 20x. Well, the x's and the y's cancel, and this means y equals x. This is very helpful. Since y equals x, I can plug this into my third equation that we haven't used yet. So right now I'm just substituting. Plugged in your y, and you've got this equation. Well, it's a y squared, so we know we can use the quadratic formula. So you do x equals the opposite of b plus or minus the square root b squared minus 4ac all over 2a. I hope you didn't forget. Now we know area cannot be negative, so this one's impossible. So we have 142.5. I'm going to square that because we know that it's x times y and x equals y. So you're really plugging it into this equation. So it's 142.5 squared. So my max size is 20,306 feet squared. Not too bad, huh? All right, pause and try yours. All right, you're given XYZ is our formula because you know that's volume, nothing exciting. 2xy plus 2xz plus 2yz is actually the formula for surface area. So this you should know. So this is surface area. And I said it had to be 6. So we set it equal to 6. I just reduced this by dividing by 2 so my numbers were smaller. So now we have to do our original formula. So we're finding our formula, which is our original xyz minus lambda times my constraint. Remember you set this equal to 0, so there's a minus 3 back here. You're going to take that and distribute your negative lambda through. Trying to write small so we can fit this all on here. It's not going very well. All right, now we have to do our derivatives. So we have to do f of x. F of x gives us right here yz minus lambda times y minus lambda times z. And that's all we get there. Now let's do f of y. Now this in here is xz minus lambda x. Oops, my lambda went away. Minus lambda y. Hope you're doing well. And then f of z equals xy minus lambda x minus lambda y. Oh, I did this last one wrong. That's minus lambda z. Come on, there it goes. Sorry about that. All right, we've got our 3 derivatives. Now we have to do our derivative with respect to lambda, which is going to be minus xy minus xz minus yz plus 3. Okay, everything should be going good. Now set these things equal to 0. And we've got to solve. So we want to take this guy and we're going to solve it for lambda right here. Let's get ourselves a different color so we can see what's going on because we're setting these equal to 0. So if I'm setting this equal to 0 and I'm solving for lambda, I'm going to move the 2 lambdas to the other side. So yz equals lambda y plus lambda z, factor out your lambda, divide by yz, or y plus z, I'm sorry, over y plus z, and this equals lambda. All right, you should have done the exact same thing for x and for the z one. So you should have solved all 3 of these. And when you did that, your second one would have been xz over x plus z equals lambda. And your third one follows the exact same pattern, and you would have had an xy over x plus y equals lambda. So you should have had your 3 lambda equations here. So now we're going to set them equal to each other. So yz over y plus z equals xz. We're going to do them 2 at a time. I'm using these 2 over x plus z. Now we're going to solve this. We're going to multiply up. So this is yz times x plus z equals xz times y plus z. multiply through, you get y zx plus y z squared equals x y z actually, plus x z squared. Now when we cancel, these two are the same, so they cancel out. Divide by z squared on both sides, and we end up with x equals y. Now you're going to do the same thing with these two. So you're going to go xz over x plus z equals xy over x plus y. Same work, and you end up with y equals z. All right, so now that we have this, we know that x equals y equals z is what this means, which is very handy when it comes into the equation. So now we're going to go over to, so now we have all three of these. We know since x equals y equals z, we can plug it into this equation here. So I'll have minus, let's just use x's, x squared, come on, right, minus another x squared, minus another x squared, and I'm going to subtract the 3, equals a negative 3. So this is a negative 3x squared equals negative 3. X squared equals 1. So x equals 1. Has to be positive because it's area. Well, if x equals 1, y equals 1, and z equals 1, since they're all three the same, and our answer is 1, 1, 1. Kind of weird, huh? I hope you did well. Good luck on your homework, and make sure you post questions if you have any.